The purpose of this video is to introduce and give examples for what is in 2.8 in our pre-calculus book, Zeros of Rational Functions. Our objective is to solve for these zeros in the rational functions. Now, things that we already know that we're going to utilize are when we are solving, like in example number 1 where it says solve x minus 3 is equal to 0. Well, we'll go, and you don't necessarily have to show any of this. We can see the answer, but you would, for example, add 3 to both sides. And we would come up with a value x is equal to 3. Well, remember what that 0 means graphically. If we were to graph y is equal to x minus 3, the y-intercept would be at a negative 3, and our slope is 1. So we have a slope of 1, so 1x minus 3. And so as a quick graph, it would look something like this, and it should be a line. And on this line, that's sort of a line, the value of x equals 3 is where it crosses the x-axis, and that's exactly what we're finding. Now on our second example where it has x, and this should be x squared minus 2x minus 8 is equal to 0, the graph will be a little more involved because it's squared and that's a parabola. But when we find our zeros, it'll be x minus 4, x plus 2 is equal to 0. So the value of x equals 4 is a 0, as is x equals a negative 2, because either of those values make one of the quantities 0. Graphically, what that means is, if we're able to do this, at a negative 2, so at this value at a negative 2, it's going to cross the x-axis, and at the value of 4, it's going to cross the x-axis. Also, the y-intercept's a negative 8, and again, this is a quick review, but we say this is a negative 8 right here. So we know we have our zeros, and the graph would look something like this. Something like that. But the point of it is, in both cases, when we're finding a 0, it's where the graph is going to cross the x-axis. Now, for the rational, and all we mean by rational equations is that we now have a fraction. In the deal on the fraction, the situation's still the same. We're going to have to find what makes the quantity equal to 0. Well, what we find is that it doesn't matter what is in the denominator, it's the numerator that we care about. So if we set x minus 3 is equal to 0, x equals 3 is still our solution. And you might look and say, well, negative 4 makes the denominator 0. Well, that's, as we'll see in later times, that gives you what's called a vertical asymptote. And in that case, that is not a 0. So the only time we have a 0 is when the numerator is equal to 0. Same way here, even if we have a denominator of x plus 4, all we care about is this part right here. So just like we did previously, we had this x squared minus 2x minus 8 is equal to 0. When we factored it to x minus 4 and 8, x plus 2, remember that our values were x equals 4 and x equals negative 2. Now, one thing to note, the graphs of these two are not going to look the same as we saw in our previous example 1 and 2. But the process that we're going to find the zeros is actually the same. So if we look at our rules, the first rule is we're going to factor the numerator and denominator. In the examples you see coming up, you'll see that they're already factored. Then we're going to divide out the wholes, and that's what we did in the previous section, the wholes where we have the same factor in the numerator and denominator. And then we're going to set the numerator equal to 0 and solve. So these 3 steps are what we're going to utilize to be able to solve our problems for today. So I'll leave this up here for a second if you, so that you can write those 3 steps down. Now, moving on, if we look at examples that are initially a lot more involved, understand that the process is the same. Now, on this number 3, it says to solve, we have quantity of x plus 4 times quantity of x minus 1 over x plus 4. Now, it's already factored for us. That was our step 1. But in this particular case, note that you have the same exact factor in the numerator and denominator. So as far as we're concerned, we can divide those out. Now remember, we cannot have negative 4 because negative 4 is a whole. But we're left with x minus 1 is equal to 0. So when we solve it by adding 1 to both sides, we'll get x is equal to 1. So what we did, our first step was done for us on the factoring, and a lot of times we'll see the first step is done before us. We divided out the wholes, that was our step number 2, set the numerator then equal to 0. Next example, much more involved, but already factored for us. And again, our process is to divide out the wholes, so we note that x cannot be equal to a positive 2. But then we don't really care about this part right here as far as solving. We know that x equals a negative 5 makes the denominator 0. But when we're solving, when it's set equal to 0, we put what's left in the numerator set equal to 0. And once we do that, we look at this part, the quantity of x plus 2. And if you were to graph this, the value of x equals negative 2 will be a 0. It's where the graph will cross the x-axis. As well, x equals negative 4. So those are our solutions. As a final example, and this is actually 5, if we wanted to solve something like this, now this will be 4 minus x squared over x minus 2. Now one thing you need to do, we'll set this equal to 0. And this 4 minus x squared, the first thing that we'll do here, we'll write this down below because we can factor this. We factor out a negative, and what happens is that if you factor out a negative out of the numerator, you're left with a negative 4 plus x squared. And then that's again divided by x minus 2. I'm going to put parentheses around x minus 2, set equal to 0. And then lastly, the reason why we factored out that negative, notice that factoring out the negative, opposite of negative 4 is still 4. Opposite of x squared is still negative x squared. But in factoring that out, that allows us to put it in a form we're used to seeing, x squared minus 4. So what we did was we reversed our negative 4 and our x squared over x minus 2. And what that factors to is the following. Negative quantity of x plus 2, it's a difference of squares, and x minus 2. And then that's divided by x minus 2. Now, as far as our steps, this is equal to 0. We'll divide out the wholes. So note that x cannot be equal to 2. And then we're left with the opposite of x plus 2 is equal to 0. Well, in this case, the answer we're going to end up with is actually negative 2, because notice that if we substitute a negative 2 in here, we will get 0. So we could go through the steps to solve, but our value is x is equal to a negative 2. And the key thing about this is that if we were to graph this original function, if we were to go y is equal to 4 minus x squared divided by x minus 2, though we don't know everything about that graph, we do know at x equals negative 2, that graph will be crossing the x-axis. So the problems that you're working on today on your assignment will relate to solving these rational equations.